So here's a problem related to percent yield. I have an equation, silver nitrate, it's aqueous. Reacts with sodium chloride, that's also aqueous. We get a solid, silver chloride, and sodium nitrate, which is aqueous. So just a reminder, anytime you look at an equation, try to imagine what it would actually look like. Silver nitrate is going to be a clear solution. Sodium chloride, aqueous sodium chloride is going to be a clear solution. Silver chloride will be a white solid, and sodium nitrate, aqueous sodium nitrate, will be a clear solution. I wrote the molar masses up top here. So grams per mole, remember that's the unit for molar mass. And a couple terms, we've got percent yield. Percent yield is going to be, you're going to be calculating that by this formula, and that's deals with your experimental yield. So this would have to be measured in lab. If you're looking at some problem in a textbook, they might tell you, in lab you collect this much. Theoretical yield. This is calculated with stoich. For you noobs, that's stoichiometry. So this is the type of question we need to answer. What is the theoretical yield of silver chloride if 0.742 grams of aqueous silver nitrate is reacted with excess NaCl? So I'm going to underline a few things. Number one, we've got theoretical yield. Okay, so theoretical yield, we're using, it's just stoichiometry. This is just on the page, we do a calculation, we figure it out. I'm going to also underline silver chloride, because that is the product that I'm interested in finding. And we have 0.742 grams of silver nitrate, right? It's aqueous silver nitrate. So this is what I'm starting with. I'm trying to figure out how much silver chloride is going to be produced from it. They tell us it is excess NaCl. That means we have enough NaCl to react every bit of the silver nitrate. Okay, so first thing I need to convert to moles, then I can use the balanced equation. And there are no coefficients that are written, it's all ones. 1 mole of silver nitrate can produce 1 mole of silver chloride. Now notice, if you don't write this step, it's not going to change your answer. But if you don't write this step, then if somebody's looking at your work, they might not know that you understand what's happening in this reaction. So this, although it looks like the numbers are just ones, doesn't matter. It really does matter. That's a very important step. Okay, so you should think about the answer that you're going to get before you put it in the calculator. We've got 0.742. We're multiplying by a number that's smaller than the number in the denominator, so it should be smaller, right? 0.742 should get smaller. Boxing it, that's my answer. 0.626 grams of silver chloride is our theoretical yield. So notice we didn't do it, we didn't do any experiment with that. Not that I'm going to do an experiment here, but we didn't do an experiment with that. We can just calculate it using what you know about stoichiometry. So for number one, what is the percent yield if you go into lab and you only collected 0.502 grams of silver chloride? So you can see that our percent yield is less than 100%. We expected to collect 0.626, we only collected 0.502. It could be that we collected more. You can get above 100% yield. You can go into lab and for some reason you have extra. But in this case we don't. So our formula, experimental yield over theoretical yield times 100. the percent yield is